Hello, my name is Hassan Raza, and today I will be showing you communication between a client and a server using SSL. This is part of the CSDP PMA, and in order to start the process, I would like to start off with a brief ethics statement. I confirm that in carrying out this activity, I used legal copies of software and tools. I took adequate precaution to ensure that no personal, corporate, or any other data not directly relevant to the research was covered. So our test environment basically consists of 3 virtual machines, a Windows 10 web server and Ubuntu web server. Both of them are running Apache and OpenSSL, and we have a Web Dojo, which is going to be our client machine. So the goal of this exercise is to basically show you client-server communication using using SSL TLS, and we'll show you the 4 stages: the TCP handshake process, the SSL TLS handshake, the SSL TLS cipher exchange, and finally the TCP session teardown. Because I'm actually going to be capturing my data using Wireshark, and this will be outside the virtual environment, I've taken precautions to make sure that I'm not capturing any data from the local network that I'm on right now. And just to give you that confirmation, my laptop is now in flight mode, so there's no communication in and out of my laptop, only within my laptop and the virtual machines. So I'd like to go to the Wireshark and show to you that the only devices that we are capturing on is the virtual host, and at this stage I would like to start off my capture. So my capture has been started. So now I'm actually going to go to my Web Dojo machine, and I'm going to put in the IP address of the Ubuntu server. So this is an example of a good certificate, because this actually shows you the certificate authority, the website IP address that we connected to, and it also gives you a lot of good information in terms of the cipher algorithm that was used to set up the connection. Okay, now what I'd like to do is show you an example of a bad certificate. So now immediately you can see here that it says the connection is untrusted. The reason why you're seeing this message is because I have used a self-signed certificate, and the certificate is not being validated against any certificate authority. Let's take a look at the technical details. It tells you that it's an invalid certificate, it is self-signed, and it doesn't have any common name, and it's expired. Okay, so typically you would not want to accept this kind of a certificate, but because we are in a test lab environment, I will allow this to go through and basically allow the exception to go through, and there's my sample SSL test page. Now at this stage what I'd like to do is close the client session now and go to Wireshark and basically stop the capture. Okay, now in order to analyze this data better, what we're going to do is actually run some filters. So I'll actually start off with the tcp.ack filter. As you can see in this particular filter here, what I have here is the communication between the client machine and the Ubuntu server. So the client machine is sending a SYN packet, and you got a SYN-ACK from the server, and finally the ACK packet. So this basically shows you the TCP handshake. Okay, the next thing I'd like to show you is the SSL handshake. So in the SSL handshake you can see the client hello, the server hello, and the certificate that is being sent through. So if you take a look at the client hello, what comes through in the client hello is basically a list of all the ciphers that are being proposed by the client machine for the communication with the server. Okay, the server then responds back and says I would agree with this particular one, and this is what we saw on the certificate. Finally, the next stage after that is the server sends through the certificate, and you can see the certificate there. If we open up the certificate, it will show me all the details, and this is what we saw earlier on. And also, as part of the communication from the server, it actually sends through a server key. This is a pseudo-random key that is used as a session key between the server and the client. Okay, this concludes the SSL handshake. Now we go to the SSL cipher exchange. In this case here, what the client says is the client comes up with a new session key and sends that session key to the server. So if you take a look here at this particular key here, we can actually see the new key that is proposed here. So it's basically proposing this key now, and then what would happen is the server would then respond back with a new session based on that new session key, and that's what we see here. And then from then onwards, all the communication is going to be encrypted. Now the way we can see the encrypted communication is by using the SSL.alert message, and this filter actually shows you all the encrypted communication that is going back and forth between the client and the server. Finally, now that we've seen the cipher exchange and the SSL handshake, we're going to talk about the TCP teardown. In the TCP teardown, we will actually see a FINAC message that is being sent from the server to the client. Okay, so we can see that FINAC message being sent from the server to the client, and then there's also a FINAC message in response from the client back to the server. So, and then this is then followed by an acknowledgement packet, and this finally concludes the client-server communication. And this is an example of how SSL communicates. I hope this was a useful session, and I hope you enjoyed it. Thank you.